Hello everyone, this is Wagada Ronald taking you through Newton's third law of motion. So it states that the action and reaction forces are equal but opposite. Now before we talk about reaction, we have to first talk about weight. So this is the product of mass and acceleration due to gravity, and it's given by the formula W equal to mg, where g is the acceleration due to gravity, and in physics our g is given by 9.81 meters per second squared. Now if a person holds a brick, he feels it exerting a downward force on his hand, and if he releases the brick will fall to the ground. The force this person felt on his hand is now free to pull the brick towards the ground, and this force is known as weight of the brick and is due to gravitational attraction of the earth on the brick. So this will be the brick and this will be the weight of the brick. It is acting towards the gravitational earth's attraction. So what we should know about the weight is that it is always acting vertically downwards, in other words towards the center of the earth. And second, notice that the weight of all bodies acts through a point called the center of gravity. So this is the center of gravity if it is symmetrical, and that is where weight acts from. And thirdly is that weight is an inescapable force on earth. In other words, all bodies have weight, all people have weight, all animals have weight, and everything, all birds, so all bodies have weight. Now that we know weight, we can now discuss about reaction. Now if this very brick of weight 14.7 newtons is placed on a rough horizontal table, it does not move, and we say that the brick is in equilibrium. So in that scenario, making an assumption that the gravitational attraction has now ceased would be unrealistic, because it is always there attracting bodies. So there must be an opposing force exactly equal to 14.7 newtons, which is the weight of the body, and acting vertically upwards and also through the center of gravity of the brick. So this upward force is what we call normal reaction of the brick from the table. Normal in the geometrical sense of being at right angles, so it is reaction, but we add there the word normal because it is acting perpendicular to the surface. So that is what reaction means. So Newton's third law, always to every action there is a reaction. Now the action in this case is the weight of the body acting on the flow. Now the flow also reacts with a reaction equal in magnitude but opposite in direction. And with that law, we can explain some of the observations. And one of the observations is why hands are drawn backward when catching a fast moving ball. I think you can see this is a ball coming to this person, and as he holds it, the hands will be drawn back continuously until the ball comes to rest. This can be magnified here. They are drawn back continuously until the ball comes to rest. Now why is it so? By drawing the hands backward, the time taken for the ball to come to rest is increased, but momentum is constant. Why is momentum constant? Because momentum is equal to mv minus mu. So v will remain 0 and u remain constant, as will remain the initial speed with which this ball reached the hand here, and at this point is the final velocity, which is 0. Now the ball is at rest. So change in momentum will be constant, but time taken will increase. I think you can see from here, the time taken for ball to be from here up to here will be higher. Now because of that, the rate of change of momentum reduces, and therefore the impulsive force exerted by the ball on the body in accordance to Newton's third law of motion also reduces. Why is it reducing? Because we know that the force is equal to change in momentum over time. So as time increases, the force has to reduce. And in that case, less pain will be felt in the hands of the person holding the ball. Another observation is as to why a long jumper should normally land on sand instead of a hard surface like a concrete. So I think I can see this is a long jumper and this is sand. So why is it so? Newton's third law helps us to explain that in the following way. By landing on sand, the time taken by the long jumper to come to rest is increased compared to landing on a hard surface. But momentum change is constant. This reduces the rate of change of momentum, thereby reducing the impulsive force exerted on the long jumper in accordance with Newton's third law of motion. Remember, impulsive force is given by change in momentum over time taken. So when this one remains constant, but this one increases, this will also have to reduce because this is inversely proportional to time. And in that case, less pain will be felt in the feet of the long jumper. So basically, a long jumper lands on sand such that he feels less pain in the feet. Remember, action and reaction are equal. Therefore, if it was hard, he will land with a higher force, and therefore the reaction will also be higher, and he may receive a lot of damage. So they will be sound to increase the time so that the impulsive force reduces. Another observation here is as to why a spongy material or a mattress is provided for a high jumper to land on. As you can see here, this is a high jumper, but here they provide a spongy material for him or her to land. Why is it so? Newton's third law can help us explain that. So a mattress is soft, and it prolongs the time of the jumper, which the jumper needs to come to rest, instead of coming to rest instantly. So this results so the resulting force of impact becomes smaller and the jumper feels less pain and is free from injury. So that has been the end of our lesson. Thank you for watching. Please subscribe to my channel, Rowa e-learning platform. I remain Ronald Wargada. Thank you.